And now we need to talk about precipitation reactions. So the first step is you guys learning how to use that solubility rule table to predict if a substance is soluble or not. The next step now is going to be using this in a double replacement reaction to predict if we'll form a precipitate. I know it sounds like a lot. Hang in there with me. Okay. A precipitation reaction is a reaction where you mix two aqueous solutions together and a solid crashes out, which is what this awesome looking picture is of right here. Okay, in here we have an aqueous solution of lead 2 nitrate, and in this burette we have an aqueous solution of potassium iodide, and you can see it's making an insoluble yellow solid here, which is lead 2 iodide. And we can predict this. We can predict that this would happen by doing a double replacement reaction and then checking the solubility of each product. So let's look at that. So here's what's happening if you're a visual person. We're taking an aqueous solution of potassium iodide. So somebody dissolve potassium iodide in water. Take a look at your solubility rules. Potassium iodide will dissolve. Rule 2, it's got an alkali metal ion. And we're taking an aqueous solution of lead 2 nitrate. Take another look at your solubility rules. Lead 2 nitrate will dissolve because it's got a nitrate. Nitrate's also soluble. And we're saying, hey, if we mix these two together, will any of these ions meet up? Will the cation of this meet up with the anion of this, or the cation from this meet up with the anion from this, and make anything that is insoluble? And the answer is yeah, absolutely it will. If you do this, okay, the lead meets up with the iodide to make lead 2 iodide. And that, if you use the solubility rules, is going to be insoluble according to rule 3, and it would crash out as a solid. Now, the other potential product, potassium nitrate, that's not going to precipitate out because potassium nitrate is soluble. It's a nitrate, right? All nitrate salts are soluble. So hopefully you got the gist of how this is going to work. We take our two compounds, we take the cation from the first, pair it up with the anion from the second, write that first potential product. Then we take the cation from the second, pair it up with the anion from the first, write that potential product. And then we check the solubility of each of these products. The potassium nitrate, nah, that one's aqueous. The lead 2 iodide, yeah, that one's insoluble. Rule 3, we would have a precipitate form. So I want to try this, okay? And this can be a little tricky, especially if you don't quite have your ions down. I would definitely have a periodic table out in front of you, okay? I want to try and predict the products of these reactions, and then I want to apply the solubility rules. So let's do this. And I've found that the toughest thing for people is they don't know when to write the subscripts and when not to write the subscripts. And this is just going to take some practice. So if we look at this first compound, I don't care that there are two sodiums. I'm going to worry about that when I go back and balance it. What I care about right now is what is the cation? Well, the cation is the sodium cation. Yes, there's two of them. I'm going to worry about that when I balance. And then I'm going to write down what the anion is. The anion is carbonate, CO3 -2. That's my anion. So I've got sodium cations and carbonate anions in this beaker, right? That's what this aqueous solution contains. Then if we come over here, we got a type 2 metal and copper. So let's do the anion first. Chloride is my anion, Cl-1. And then the copper must be +2 because I got two chlorides with it. So here's what I got to do. I need to take my sodium cation here and pair it with the chloride anion here to make a product. Now, I don't care that there's two sodiums. I don't care that there's two chlorides. I'm going to go back and balance that at the end. Right now, I'm just worried about taking sodium and pairing it up with chloride, and they go together perfectly. It's a +1 -1. So my first potential product is NaCl. Now I need to do my other product. My other product, copper 2 carbonate. +2, -2, they go together perfectly as well. So my other potential product is CuCO3. Cool. So now, okay, you can balance or you can do solubility. I guess I would balance. The 2 sodiums and the 2 chlorides would force me to put a 2 there. But now I want to know, are either one of these products going to be insoluble? Well, now what you have to do is you have to use your solubility rules on both of these. So let's use the solubility rules on sodium chloride. Take a look at, if you got the solubility rules out in front of you, that would be great. Look at rule 1. Okay, does it have a nitrate, acetate, or chlorate or chlorate? No. Look at rule 2. Does it have an ammonium ion or an alkali metal? It's got an alkali metal. That guy is going to be aqueous. That is not a precipitate. Now let's look at copper 2 carbonate. Use the solubility rules and see if you can determine if that's going to be a solid or not. So hopefully you found that it is a solid. And you get all the way down to rule 6. No rule applies till you get to rule 6, but it's got a carbonate. So we're putting a solid there, folks. That's an S. I apologize. I'm trying to do this with my mouse. That is absolutely a solid. So this is a precipitate reaction. Reaction 1 is a precipitate reaction. We made a solid. So this is a precipitate. What we actually just wrote is called a balanced molecular equation. It's called a balanced, because we balanced it, molecular equation. And you're going to find there's 2 other ways to write these reactions, total/complete ionic or net ionic equations. We're going to get into that in a couple minutes. But right now, we're just practicing writing balanced molecular equations. Let's try number 2. Here's what I want you to do. I want you to predict the products of number 2 for me. So can you take the cation from the first, put it with the anion from the second? Watch out for the charges, right? So what's the charge of lithium? What's the charge of sulfate? Can you put that together correctly? Okay. And then can you take the cation from here, sodium, put that together with the anion from here, nitrate? Can you list those products? Okay. So my first potential product, I'm taking lithium cations, putting it together with sulfate anions. Well, I'm going to need 2 lithiums to cancel out that sulfate. So my first potential product is Li2SO4. That's my first potential product. My next potential product, sodium cations with nitrate anions. So my next potential product is NaNO3. They go together great. NaNO3. Now, you could balance. I got 2 lithiums, so I'm going to put a 2 there. 2 nitrates, 2 sodiums. I'm going to put a 2 there. Now it's balanced. And now we need to bust out our solubility rules and see if we made a precipitate or if we're going to have no reaction. You're only going to get a reaction if you made a solid. So let's look at lithium sulfate. Rule 1 doesn't apply, no nitrate, acetate, or chlorate, but rule 2 does apply. I got an alkali metal, so we're going to put an AQ there for that guy. Sodium nitrate, rule 1 applies. It's got a nitrate. Both of these products are aqueous. So when that happens, you did not make a precipitate. So you need to write no reaction there. That lets me know that you know that no solid formed, right? This was a no reaction. Why don't you try number 3? Okay, lead's a type 2 metal. You have to figure out its charge based on how many acetates it's with. Try and predict the products here for that guy. I'm going to write this one on the board because I'm tired of using my mouse. All right, let's take a look. So that's lead +2. I'm going to write that down. And that's acetate, C2H3O2 minus. I don't care that there's 2 acetates. I'll worry about that later. That's sodium, Na+1. And that's sulfate, one of the polyatomic ions you're memorizing, SO4 -2. So I need to take this lead +2, pair it up with the SO4. They go together great. That's just PbSO4. And then my other product, sodium's +1, acetates -1. They go together great. I'm out of room. NaC2H3O2 +1 -1. They just went together awesome. Okay. So now what do I need to do? Well, now I could balance. So I got 2 sodiums. I'm going to put a 2 there. 2 acetates, 2 acetates. It's balanced. It's a 1, 1, 1, 2. So that guy's balanced now. And now we're going to use our solubility rules. So we need to use the solubility rule for lead 2 sulfate. So take a look at your solubility rules. Rule 1, nope, no nitrate, acetate, or chlorate. Rule 2, nope, no alkali, metal ion, or ammonium ion. Rule 3, nope, no chloride, bromide, or iodine. Rule 4, yep, we got a sulfate. But keep reading. Lead 2 sulfate is one of the exceptions. This guy is a solid. That guy is a solid. Then we got sodium acetate here. This would be rule 1. Acetate salts are soluble, and that guy's aqueous. So this is a precipitate reaction. If you mix these 2 aqueous solutions, that solid is going to crash out. You're going to get the white solid lead 2 sulfate. Cool. All right, folks. Molecular equations versus net ionic equations. And oh, my goodness. Well, I'll tell you what. Let's just use this guy. And we'll do some more. So what we just wrote, folks, is called the balanced molecular equation. I'll tell you what, this one might be a little tricky, so we'll actually do an easier one. What we have been doing are called balanced molecular equations. I don't want to start with that one because it's a little tough. That's like a medium level difficulty. I want to start with like the easiest one ever. So let's do this guy. Let's take silver nitrate, an aqueous solution of it, and let's mix it with an aqueous solution of potassium chloride. Okay. Predict the products for me. Apply the solubility rules of those products. Go ahead. We'll start there. Give me a balanced molecular equation. So hopefully you took the silver +1 ion, paired that up with the chloride -1 ion, and you got AgCl as the first potential product. Then hopefully you took the potassium +1 cation, paired it up with the nitrate -1 anion, and you got the next kind of product is KNO3. So what I'm hoping we got. Awesome. Now you got to apply the solubility rules. And hopefully you found that silver chloride is insoluble, exception rule 3, and potassium nitrate aqueous rule 1. Okay. This is a balanced molecular equation, and it is balanced. It's 1, 1, 1, 1. This is why I picked that one, because it's super easy. Now what I want to write is called the total or complete, either term is fine, ionic equation. And what the total or complete ionic equation does is it dissociates everything that's aqueous. So it's going to dissociate everything that's aqueous. So we're going to write the total/complete ionic equation for this reaction. We're going to break apart everything that's aqueous into its ions, because that's what it would look like. Like it's actually dissolved in water as its ions. So we're going to break silver nitrate apart, and that's going to be Ag plus AQ plus NO3 minus AQ, dissociated into its ion. We're going to break potassium chloride apart, so plus K plus AQ plus Cl minus AQ. And you keep the precipitate together. The precipitate is the solid, the insoluble substance. That is not dissolved. That is not broken up into its ions. That stays together. And then we're going to break this guy apart. That's going to be K plus and NO3 minus. And that's our balanced, complete total ionic equation. Now, this one was pretty easy because everything had a coefficient of 1. Everything has a +1, -1 charge. It's pretty awesome. It goes together pretty great. We're going to talk about moving subscripts and distributing coefficients here in the next example, but I want to start really simple. There is one other way to write solubility reactions, and that is a net ionic equation. The net ionic equation eliminates spectator ions. What's a spectator ion? A spectator ion, like the name suggests, what's a spectator? A spectator is just somebody that watches. A spectator ion is not involved in making the solid. A spectator ion does not go into the precipitate. It is aqueous on the reactant side, and it's aqueous on the product side. It was just along for the ride. It did not have anything to do with making the precipitate. So what you're looking for when writing a net ionic equation is to find ions that are aqueous on the left and on the right. So we have a aqueous K plus ion here. We have an aqueous nitrate ion here. And we are left with Ag plus AQ plus Cl minus AQ goes to AgCl solid or precipitate. The spectator ions, potassium and nitrate, they were aqueous on both sides. They had nothing to do with making my solid. I could have used some other silver soluble salt and some other chloride. Like I could have used silver acetate. I could have used sodium chloride, right? The nitrate and the potassium had nothing to do with making my silver chloride. They were just paired up with the silver and the chloride initially, and they never come together. So that's my net ionic equation. Now this one was pretty easy because all the coefficients were ones and everything was +1, -1. So let's look at one that's a little tougher. Okay, next. Any questions on balanced molecular, complete ionic, net ionic? Right, let's try another one. Do this guy. Take an aqueous solution of lead-2 nitrate. Let's allow that to react with an aqueous solution of lithium iodide. I want you to predict the products. I want you to use the solubility rules, and I want you to balance. Go ahead.
What is the charge of lead?
So lead's a type 2 metal. It can be +2 or +4. You got to use the nitrates. So since nitrate's -1 and you got 2 of them, that's a total of -2. So this lead must be +2.
Okay, got it. Yep.
Take another second. All right. If we look at this, lead's +2, nitrate's -1. I don't care that there's 2 nitrates. Okay, and if we look here, lithium is +1, iodide's -1. So lead-2 goes with iodide. My first potential product is PbI2, lead-2 iodide. So lead's +2, iodide's -1, so I need 2 iodines. My next product, lithium's +1, nitrate's -1. So my next product, LiNO3. So those are my 2 potential products. Now we got to balance and we got to apply the solubility rules. So let's balance. I got 2 iodines. I'm going to put a 2 there. I got 2 lithiums and 2 nitrates. I'm going to put 2 there. Now we're going to use the solubility rules. So lead 2 iodide, that's insoluble, solubility rule 3. Rule 1 does not apply, no nitrate, chlorate, or acetate. Rule 2 doesn't apply, no alkali metal ion, no ammonium, but rule 3 does apply, we got an iodide. Okay, lithium nitrate, that's going to be rule 1. That's aqueous. Cool. So that's my balanced molecular equation. Hopefully you got that. I want to do the total / net ionic together now because this is far more complicated. So I want to do the total / complete ionic equation together. Here's what we've got to do. This is tough. When you dissociate salts, if I have a subscript that's telling me a number of that, so like this means 2 nitrates, that 2 comes out in front and becomes a coefficient. And if I have a coefficient, I have to distribute it. So let's look at this first one. So we need to break this apart because it's aqueous. So this is actually lead plus 2 ions and 2 nitrate ions. See how that's a lead plus 2 and 2 nitrates? I had to bring that 2 out in front. And then this is actually 2 lithium cations and 2 iodide anions. Let's pause, look at the reactants. See how that's a lead plus 2 and 2 nitrates. See how that's 2 lithiums and 2 iodides. Now we come over here, and this is where you can't get breakup happy. You got to keep the solid together. Do not break the solid apart. So lead 2 iodide, that stays together. That's insoluble. That does not get dissociated. So you leave that one together. But now we need to distribute, because I have 2 lithium nitrates. I'm going to have 2 lithium cations, and I'm going to have 2 nitrate anions. Just like that. That's my total complete ionic equation. See how it was a little more complicated? I had to pull stuff out front. I had to distribute. It's just tougher. It's tougher. And now I want to write the net ionic equation. The net ionic equation eliminates the spectator ions. So I want you to look at the complete ionic equation. What are my spectator ions in this reaction? Can you find the spectator ions in that reaction? So hopefully you've identified the 2 lithiums and the 2 nitrates as the spectator ion. Once you've identified and eliminated the spectator ions, we can write the net ionic equation. That's going to be lead plus 2 plus 2 iodides makes lead 2 iodide. That's my net ionic equation. How we feeling? Let's do a tough one. And if you can do this tough one, then you can do any of them. Okay, so let's do one. So like that's like a 4 out of 10, 10 being the hardest, right? Let's do like a 8 or something crazy. Okay. I want you to predict the products, balance, and apply the solubility rules to the products. Then stop, because if you jack this up, the rest is going to be jacked up. So take like a minute, 2 minutes, predict the products, apply the solubility rules, try to balance, and we'll check in. So if we're trying to do the balanced molecular equation and stopping. So what are the ions that we're moving around? Well, aluminum is +3 and bromide's -1. I don't care that there's 3 bromides. I'll worry about that when I balance. Sodium is +1. I don't care there's 2 sodiums. I'll worry about that when I balance. And then carbonate is -2. So aluminum and carbonate need to get paired up, but this is +3 and that's -2. So this is a swap and dropper. So this is going to be Al2CO33. And then sodium's +1, bromide's -1. So my other product is NaBr. That was an easy one. Any questions on the formulas of the products? All right. At this point, I would balance. So 2 aluminums, I'm going to put a 2 there. 6 bromines, I'm going to put a 6 there. 6 sodiums, 3 carbonates, I'm going to put a 3 there. Then we're going to use the solubility rules. So aluminum carbonate, you're going to make it all the way down to rule 6, right? Look at the rules. Nothing applies till you hit 6. That's a carbonate salt. That's insoluble. Sodium bromide, that's aqueous, rule 2. Okay, hopefully that went all right. Now I want you to try to write the complete/total ionic equation for that reaction. Go ahead. All right. Here we go. Lot of moving parts. 2 aluminum plus 3 cations. Hopefully you got that. 6 bromides. 3 bromides per molecule times 2. That's 6 bromide ions. 6 sodiums. 2 sodiums per molecule times 3. That's 6 sodium cations. 3 carbonates. Precipitate. Do not break it apart. And then 6 sodium cations and 6 bromide anions. 6 sodium cations and 6 bromide anions. There's our complete ionic. Any questions on that? We had to distribute stuff. We had to pull stuff out and multiply, right? Gets a little crazy. Okay. If you don't have any questions, then try the net ionic. Eliminate the spectator ions, write down what's left. So the spectator ions are going to be the 6 sodium cations and the 6 bromide anions. And we are left with 2 aluminum plus 3 cations plus 3 carbonate polyatomic anions goes to aluminum carbonate solid. And that's our net ionic equation.